Beginning our investigation, we must know the concepts and ideas of physics to figure out who is at fault during this fatal car crash. We will begin with the forces of motion acting upon the cars during the time of the accident. The first force on the vehicles is the force of gravity. The force of gravity is the acceleration at which the Earth pulls the object at its center of mass at 9.8 meters per second squared. Fg can be calculated by taking the mass of the object and multiplying it by gravity, which equals Fg equals mg. Against the force of gravity is the normal force, which the Earth pushes against the car with the same force. Without this normal force, the car would be accelerating through the Earth, so it balances out with the Fg. When both vehicles accelerate, it has an F net force, which is the force at which it accelerates or decelerates. When the crash occurred, the vehicles are in motion of only the force of friction in the x vector. Force of friction can be calculated by mu Fn equals Ff. Mu is the coefficient of friction, while Fn is the normal force. The coefficient of friction can either be static or kinetic. Since the vehicles were both moving, we can assume it will be kinetic mu because they are not stationary. This is all we need to know for the forces acting on the two vehicles. These vehicles crash together, momentum occurs before and after the event. We know that momentum is always conserved, so we can prove the statements of the drivers. Momentum can be calculated by P equals mv, which m is the mass and v is the velocity. However, we would think we could use kinetic energy to solve this problem. This is false because kinetic energy is not always conserved, so it will not be reliable to use this formula. Momentum would be the perfect way to resolve this situation. Lastly, using components from the values of momentum will help us solve the velocity before the crash, so we need to work backwards and find the velocity after the crash. This is all we need to know for our investigation.
Part 3, Section 131 states that when rapid intermittent flashes of red light are exhibited at an intersection by traffic control signal, the driver of a vehicle approaching the intersection and facing the flashes of red light must cause the vehicle to stop before entering the marked crosswalk on the near side of the intersection, or if there is no marked crosswalk, then before entering the intersection, it must not cause the vehicle to proceed until it is safe to do so. When rapid intermittent flashes of yellow light are exhibited at an intersection by traffic control signal, the driver of a vehicle facing the flashes of yellow light may cause it to enter the intersection and proceed only with caution, but must yield the right of way to pedestrians lawfully in the intersection or an adjacent crosswalk.
This means that a driver facing a flashing red light at an intersection must stop before the marked stop line or crosswalk. If neither marking is present, then the stop must be made before entering the intersection. Once stopped, you may not proceed until it is safe to do so. A driver facing a flashing yellow light must enter the intersection with caution, yielding to pedestrians in the same manner as a flashing red light requires. Since Mr. Sandor was at a flashing red light, this means he was supposed to come to a complete stop before the intersection, not proceeding until it was safe to do so. Miss LaRusso had a flashing yellow light, meaning she was allowed to proceed to the intersection with caution. This means Miss LaRusso had the right of way before the collision occurred between the two vehicles.
So, to start off these calculations, we know that the car was traveling in the positive y direction while the truck was driving in the negative x direction. We know that the car and the truck accident occurred 13 meters past the stop line. Following the collision, we know that the car headed off 33 degrees in relation to horizontal, while the truck headed off at 7 degrees in relation to horizontal. Also, we know that the truck skidded 11 meters before stopping, while the car skidded 8.2 meters before stopping. So, to find the coefficient of friction, we used some of the information that was given to us. We know that the normal force is equal to the mass times gravity, which is equal to 130 newtons, and the force of friction in this case is equal to the force applied, which was given to us as 100 newtons. So using the formula Ff equals mu Fn, we can solve that the coefficient of friction for the car is 0.77, while the coefficient for the truck is 70% of that, which is 0.54. So, in order to determine the speed of each vehicle just before the collision, we'll need to first find the speed of each vehicle just after the collision, because we'll be using momentum. So, using some of the info provided, such as the mass of the car, the mass of the truck, and the distance each of them traveled, we can find this out. So for the car, we make an Fnet statement first, finding out that acceleration is equal to 7.5 meters per second squared. Using this, we can use the formula velocity final squared equals velocity initial squared plus 2AD. Plugging in our numbers, we can find out that the initial velocity just after the collision is equal to 11.09 meters per second for the car, and for the truck, it is equal to 10.8 meters per second. To determine the speed of each vehicle just before the collision, we can use the idea that momentum is always conserved. Because of this, we can find the momentum after the collision and use it to find the velocity just before the collision. So we know that the car skidded off 33 degrees relative to the horizontal. We also know the mass and the velocity just after the collision. So we can plug this into our formula, P equals mv, to give us the x component as well as the y component of the momentum for the car. We can then do the exact same for the truck. We can find the x component for the truck as well as the y component for the truck. Momentum is always conserved, so we can then add up these components and find the total x component to be 89,146.2 and the total y component for momentum to be 17,743.39. Using this, we can then find the velocity just before the collision. We can use the same formula as well as mass to give us a velocity of 12.5 meters per second for the truck just before the collision and a velocity of 12.8 meters per second just before the collision for the car. To determine whether the collision was elastic or inelastic, we can find out whether kinetic energy was conserved. If kinetic energy was conserved, we know that the collision must be elastic, whereas if kinetic energy is not conserved, the collision is inelastic. So the kinetic energy of the car just before the collision is 8,881.9, whereas the kinetic energy after the collision for the car is just 7,695.4 joules. This shows that kinetic energy was not conserved. Same goes for the truck. The kinetic energy after the collision is much less than the kinetic energy before the collision. This shows that kinetic energy was not conserved, and therefore the collision was not elastic. So now that we have all this information, we can determine who in fact is at fault. So how will we do this? We will first find whether the car stopped at the flashing red light. So we know that the distance from the intersection stops light to the collision is 13 meters, and the maximum acceleration for the Ford Escort is 3.0 meters per second squared. So we can use the formula velocity squared equals velocity initial squared plus 2AD. We can plug in these and we know that the maximum velocity he could be traveling if he stopped was 8.8 meters per second. This shows that he in fact did not stop because through our calculations we determined he was going a lot faster at 12.8 meters per second. So we know that the car is at fault because he did not stop at the flashing red light. However, the truck driver is at fault as well. From this picture, it shows that the accident occurred with the car fairly decently in the intersection where the truck has barely entered. This shows that the truck did not use caution at the flashing yellow light, which he should have. If the truck were to use caution, the accident may have been avoided. So, in conclusion, the truck driver as well as the car are at fault due to their bad driving skills. However, not only were the car and truck drivers at fault, they also lied. Their statement said that the car driver made a full stop. However, he did not. The truck driver also stated that he was traveling at only 6.7 meters per second before the accident. However, through our calculations, we determined that he was going much faster. So, both of them were at fault and both of them lied.